The engineers stood in silence around the captured tank, their boots crunching softly on the frozen ground. The metal before them was scarred, blackened, and still warm in places where the fighting had only just ended. For years, they had believed their machines were unmatched, precise, disciplined, and superior in design. But now, as they examined this Soviet T-34 up close, a troubling realization began to take shape. If this tank was what they would face in numbers, then everything they had built might already be outdated. The question hung, unspoken in the cold air. Had they misjudged the future of armored warfare? At this point in the war, Germany's armored forces had already achieved remarkable successes. The early campaigns in Poland and Western Europe had reinforced a powerful belief within German command. Their doctrine, known for speed and coordination, had proven effective. Tanks worked closely with infantry and aircraft, striking quickly and decisively. The machines themselves, like the Panzer III and Panzer IV, were considered reliable and efficient. In plain terms, the system worked. But war has a way of exposing assumptions. By the summer of 1941, German forces pushed deep into Soviet territory. The invasion had begun with confidence, even certainty. Early encounters suggested the Red Army was disorganized, its equipment inferior. Yet, as the advance continued, reports started to change. German units began encountering a new kind of tank, one that did not behave like the others. This was the T-34. At first, these encounters were confusing. Standard anti-tank weapons struggled to penetrate its armor. German tank crews reported shells bouncing off at angles they did not expect. Mobility was another surprise. Where other vehicles bogged down in mud or snow, the T-34 kept moving. The problem now was no longer theoretical, so when one of these tanks was captured intact, German engineers moved quickly. This was an opportunity. By studying it closely, they could understand its strengths, and perhaps its weaknesses. But what they discovered would challenge their entire approach to tank design. The inspection began with the most obvious feature, the armor. Unlike German tanks, which used mostly vertical armor plates, the T-34 used sloped armor. In simple terms, this meant the armor was angled rather than straight up and down. This had two important effects. First, it increased the effective thickness without adding extra weight. Second, it made incoming shells more likely to deflect rather than penetrate. To the engineers, this was not just a technical detail. It was a fundamental difference in thinking. German designs had prioritized precision manufacturing and straightforward construction. The T-34, by contrast, showed a willingness to sacrifice refinement in favor of battlefield advantage. The welds were rough, the interior was cramped, but the results spoke clearly. Then came the gun. The T-34 was equipped with a powerful 76mm cannon. It could engage German tanks at ranges where German weapons struggled to respond effectively. This meant Soviet crews could strike first and often with decisive results. At the front, this translated into a growing sense of unease. German tank commanders were used to controlling engagements. They relied on communication, coordination, and superior optics. But against the T-34, these advantages were less certain. When a tank can survive hits and return fire effectively, it changes the balance. Mobility added another layer to the problem. The T-34's wide tracks distributed its weight more evenly. In muddy or snowy conditions, this made a significant difference. German tanks, with narrower tracks, often became stuck or slowed. In Russia's harsh terrain, mobility was not just a convenience. It was survival. The engineers noted this carefully. What mattered most was not any single feature, but the combination, armor, firepower, and mobility, in a way that allowed the T-34 to perform consistently across different conditions. This was something German tanks had not been designed to do. Back in the headquarters, reports began to accumulate. Field commanders described encounters where standard tactics failed. Anti-tank units requested stronger weapons. Tank crews adapted where they could, but the underlying issue remained. The T-34 was not a minor improvement. It was a shift. By late autumn, the realization was difficult to ignore. German armored forces, once seen as the most advanced in the world, were facing a machine that challenged that assumption at every level. And so, the engineers returned to their notes. They examined every component. The suspension system, which allowed for smoother movement over rough ground. The diesel engine, which reduced the risk of fire compared to gasoline engines. Even the manufacturing methods were studied, simplified processes that allowed for faster production. In plain terms, the Soviet approach prioritized quantity and practicality without sacrificing key performance. This was not what German planners had expected. Brief pause in the narrative helps to clarify the situation. Up to this point, Germany's success had relied on a combination of tactics and technology. Their tanks were part of a larger system. But the T-34 introduced a new challenge, a single machine that could stand up to that system more effectively than anticipated. The balance was shifting. The response, however, was not immediate. German industry was already committed to existing production lines. Changing designs required time, resources, and coordination. There was also debate within the command structure. Some believed improvements to current models would be enough. Others argued for entirely new designs. This debate would shape the next phase of the war. At the front, the situation grew more urgent. Winter conditions exposed further weaknesses. Engines struggled in the cold. Mobility decreased. Meanwhile, Soviet forces, equipped with T-34s, continued to operate effectively. The difference in performance became more pronounced. For German crews, this was not an abstract issue. It was a daily reality. Encounters with T-34s required new tactics. Crews aimed for weaker points, such as the sides or rear. Coordination became even more critical. But these were adjustments, not solutions. The underlying problem remained unchanged. The engineers' reports were clear. If Germany wanted to regain its advantage, it needed a new tank, one that incorporated the lessons learned from the T-34 while maintaining its own strengths. This led to the development of new designs. One of the most notable was the Panther tank. It was, in many ways, a direct response to the T-34. It featured sloped armor, a powerful gun, and improved mobility. The influence was unmistakable, but development takes time, and time, in war, is rarely available. As the Panther entered production, challenges emerged. Early models suffered from mechanical issues. Reliability was a concern. Crews needed training. The process of adaptation was not smooth. This highlights an important point. Recognizing a problem is one thing. Solving it effectively is another. Meanwhile, the T-34 continued to be produced in large numbers. Soviet industry, relocated and reorganized, focused on output. The design itself allowed for faster manufacturing. In plain terms, they could build more tanks more quickly. Quantity became a factor of its own. At the front, this translated into increasing pressure. German units faced not only capable tanks, but many of them. Each engagement carried greater risk. Losses were harder to replace. The balance of the battlefield continued to shift. Another brief recap helps to keep the picture clear. The captured T-34 had revealed a new approach to tank design, one that emphasized balance, practicality, and adaptability. German engineers understood this. They began to respond, but the timing, the scale, and the conditions of war made that response difficult. The question from the beginning still lingered. Had they realized too late? As the war progressed, the impact of this realization became more visible. German tanks improved. The Panther, and later the Tiger, brought increased firepower and protection. In certain engagements, they proved formidable, but they also came with trade-offs. Heavier tanks required more resources. They were more complex to produce and maintain. In difficult terrain, their advantages could be reduced. And importantly, they could not be produced in the same numbers as the T-34. This created a contrast. On one side, fewer but more powerful machines. On the other, a larger number of well-balanced tanks that could operate effectively in a wide range of conditions. What mattered most was how these factors played out over time. In prolonged conflict, consistency and availability often outweigh peak performance. This was one of the lessons embedded in the T-34's design. For the engineers who first examined the captured tank, the realization was not just about one vehicle. It was about a different philosophy, a way of designing for the realities of war rather than ideal conditions. And that realization had consequences. By the later stages of the war, German armored forces were no longer advancing as they once had. Defensive battles became more common. The need for reliable, adaptable equipment grew even more important. In this context, the earlier discovery of the T-34 takes on greater meaning. It was a moment when the future briefly revealed itself. The engineers saw it clearly. They understood what it meant, but understanding alone was not enough to change the course of events quickly enough. There is a quiet lesson here. In complex systems, whether in war, technology, or any field, success often leads to confidence. Confidence can become assumption. An assumption, if left unchallenged, can delay necessary change. The T-34 challenged those assumptions. It showed that effective design is not always about refinement or precision. Sometimes, it is about balance, simplicity, and the ability to perform under pressure. As the war came to an end, the legacy of this realization remained. Post-war tank design, in many countries, reflected lessons learned during this period. Sloped armor became standard. Mobility and reliability were prioritized. The balance seen in the T-34 influenced future generations of armored vehicles. The captured tank, once examined in the cold, had left a lasting impression. Returning to the opening moment, the question can now be answered. When the German engineers inspected the T-34, they did realize something important. They saw that their existing designs were no longer aligned with the demands of the battlefield. In that sense, their Panzers were becoming relics not because they were poorly built, but because the nature of warfare had changed. The realization came clearly, but it came under the pressure of war, where time and resources were limited, and decisions carried immediate consequences. And that is often how such realizations occur, not in quiet laboratories or controlled conditions, but in moments of urgency. where the cost of delay is measured in outcomes that cannot be easily reversed. The engineers did what they could. They adapted, redesigned, and responded. But the balance had already begun to shift. In the end, the T-34 was more than just a tank. It was a signal, a clear indication that the future of armored warfare would favor those who could combine strength, mobility, and practicality in a single, effective design. That signal was seen, understood, and acted upon, but not quickly enough to restore what had already begun to change. And so, the image remains. A group of engineers, standing around a captured machine, realizing that the ground beneath their assumptions had shifted. A quiet moment, with consequences that would echo far beyond that frozen field.